Hi again. In this video, I'm going to go over how to create a package in IntelliJ IDEA and what that looks like on the file system. I'm also going to talk about common packages you might have already used, and also why would we use packages ourselves. I'm going to create a new project in IntelliJ. I'll call it Package Fun. So typically we right click on our source folder and go new Java class. We want to create a new class, perhaps for our driver or as part of an OOP solution. But this time I'm going to go new package to create a package. Then I'll create a Java class like my main or my tester inside of the package. And in there I'll describe what a package is. So right click, source, new package. And I shall call this package com.example. So now we see under our source folder, there's a package. It looks like the source folder, but it's gray. It has a hole in it. On that package, I right-click, new Java class, and here's where I'm going to put my main class. So now we can see main is inside the package com.example, and we have a statement on the first line of main.java that says com.example. So this is the statement that declares what package this file belongs to. I'm going to make a little note next to this line, and I'm going to state that this package declaration has to be the first executable line of Java, meaning we could put comments above this, but all of our import statements and our type declarations need to be below this statement. So if I have any imports, they're going to go here. Add a main really quickly to the main class. And I'll take my notes in here. So I've already created a package, but I still haven't defined what a package is. So here's a quick definition of a package. So this is a grouping of related types. And by types, I mean things like classes and interfaces, etc. We've already seen packages in action. For example, java.lang. We get this imported for free. Everything inside of the java.lang package is available for Java programmers to use without an import statement. So for example, string is a type that we use all the time. We don't have to do import java.lang.string. We get string for free because the java.lang package is imported for us. But we also import other packages as we need different types and different, say, static variables. A few other ones that are common. Java.util, java.auth for a graphics library, etc. So why would you use a package? Well, there's lots of reasons that you, a programmer, might use it, or other programmers have used them, say, as part of java.lang or java.util, or if you were to go download someone else's third-party Java library and incorporate it. The first reason, and these are not in any particular order, they're all very important. The first reason I'm going to list is project structure. Let's say that we're working for Oracle. We work for Oracle. We're working on Java. We have so many files full of so many public types, and there's nested types in there, and so many things going on, right? In order to keep track of all the files, we want to have a good structure of the Java source code, right? Or even if we're working on a separate Java project that uses, some of the standard available packages in Java, we want to keep everything organized. There's thousands and thousands of files, and we don't want them all in one folder. Or even going a step further, we wouldn't want the, hundred thousands of lines of Java code in one file. That would be unmanageable, even for a single programmer. But imagine all of the issues if we were working on, say, a team and multiple people were working on that same file. It's best to divide our code up into a logical project structure so that, say, a developer can work on one area of it and not affect something that's being developed by another developer in another area. So let me show you what I mean by folders and files. Over here, it looks like there's a source folder, there's a com.example folder, and there's a main class in there. But this is actually IntelliJ giving you a project view of your project. This isn't what it actually looks like on disk in my Idea Projects package fun folder. So let me show you what that looks like. And remember, right here it looks like there's a com.example folder that represents our package. So here's my home folder. In here, I'm going to head over to Idea Projects. Here are my Idea Projects, and this one I called Package Fun. Here's my source folder, and in my source folder, I actually have a com folder. I don't have a com.example folder, which is what IntelliJ makes it look like I have. Inside of com, I have an example folder, and inside of my example folder, I have main.java. So if I were to use another package, say like com.gina, then inside of com, there would be an example and a Gina folder. So why is it named all funny like this? Com.example, why not example.com, and where did that even come from? So I'll make a little note here that packages are named in a convention such that we use a reverse domain name. So you might be familiar with a domain name. This would be something like, say, oracle.com, gonzaga.com, apple.com, maybe developer.apple.com. We have a subdomain in there. So in order to register a domain name, you have to register a name that's not already registered, right? I couldn't go buy apple.com because it's already taken. But I could go buy something like ginasprint.com if it's not already taken. So the idea is that each company already has a URL that represents their domain name. So the reverse domain name would be the domain name in reverse. So for example, in reverse, this would be com.apple.developer. And what's nice about this is instead of going specific to general, like the domain name, this goes general to specific. So if I work at Apple and Apple has a bunch of different projects going on in Java, there can be com.apple.project1 or com.apple.project2, or those might be, instead of differentiated by project name, they might be differentiated by functionality, com.apple.iOS UI or com.apple.apple TV database, something like that. I'm just making that up. So this is how our project structure is defined. It's based on reverse domain names, which should be unique for each company and should go general to specific, so that Apple is a folder inside of the com folder, and it might have several folders corresponding to different divisions of Apple or different projects or different functionalities within a project. All right, so the second one would be related to namespace management. If I wanted to, I could define my own class called string, even though there's already a string class defined. That string class is defined in java.lang, but I could have a class inside com.example, and because they're in different packages, there's not going to be a namespace or a name conflict. The third one is related to access control. So recall that there are 4 different types of access modifiers. There's public, available anywhere. There's package private, which is the one that I'm most interested in mentioning here, which is available anywhere in the package. There's also protected, which is package private plus accessible from any subclass, even if that subclass is in a different package. And then there's private, which is available within this class only. So access control is really nice. If you're developing something and you want to make sure it's only used within the package, you could use package private. Or let's say you're using someone else's library, some other code that someone else has written. Well, you'll only be able to access, since you're outside of their package, you'll only be able to access things that are public or protected if you subclass something in that package. So those are 3 main reasons to use packages. Now I want to show you how you can write some Java code in order to figure out what package a class is in. So let's say we want to figure out, is string really in java.lang like I've been telling you it is? So I could do string.class.getPackageName or getPackage.toString. Depending on the version of Java you're using, you might have access to a getPackageName here. So let's run this and we'll see that string is in fact in java.lang. So right there, package java.lang. I'm going to print this same statement, but instead of doing it for the string class, let's do it for the main class. And we'll see that because of this package statement here, we'll see that our type main is actually in the com.example package. And there it is. If you don't make a package, let's say instead I just put main straight in the source folder, your code is in an unnamed package, which is fine just for development. But if you're going to release something or you want some other developers to be able to use your code, you'll need to put it in a package so that they can specify the name of your package when they import your type. So for fun, let's make one more package. So let's make a package corresponding to, you can use your name, but I'll use mine. So com.sprint.gnet. And in here, I'll put one more class, and then I'll try and print out that class's package from this main method here, like I did earlier. So go ahead and pause the video and try and do this. I'll work through it now. So I'm going to right click on my source folder, new package. I'll call this com.sprint.gnet. Okay, and look what happened here. The com was now broken into a subpackage, example, and sprint.gnet. Now I'm going to add to sprint.gnet my other class or my other main or just something else. I don't need to put any code in here. Then I'll head back over to main and I'll have my print statement here again. So I want to emphasize that I was able to access my other class because IntelliJ inserted this import statement for me, com.sprint.gnet my other class. My other class is not in the package com.example. Print this out, and I'll show you what it looks like on disk. Oops. So here's com. Com has two folders, example and sprint. Sprint has one folder, Gina, and then in here, here's my other class. So that concludes my demo of packages in Java and specifically how to make them in IntelliJ. Thanks for watching.